Good afternoon, students. Welcome to the Term 1 session. Students who have joined so far: Akshaya, Rahul, Ankit, Nandu, Yuvika, Chavi, Manish, Pooja, Abhish, Jyoti, Gulshan, Pankaj, Shiv, Oshit, Danish, Dharmendra, Yogita, Bhavesh, Brandon, Hussain, Raj, Rij, Shlok, Shubham, Shaheen, Ayush, Ankit, and few guest students. One. Okay. Let me give you few important announcements. Give me the whiteboard. Large. Okay. Is that clear? This announcement clear to everyone? Cloud consultation time and date I will share in your group. CC, time and date I will share in cloud group by Monday morning. Okay, there is a maintenance week next week. Every center has already been informed. I am also informing you. Is that okay? Kanchan, Ayush, is that okay? Only 10 students out of 35 students have responded. Only 10 students out of 35 students have responded. students. This is very important announcement. Your center has already been informed. I am also informing you, because you have to understand, because the SLT classes are not there, that does not mean that you will not have cycle tests or lab at home or e-learning or self-study. Okay? You have to appear for your cycle tests and lab at home. You have to go through the e-learning and you have to go for self-study from the cloud books. That part will continue. Yes, you will also have MR. MR session at center there. MR and practical sessions will go on. MR and practical sessions will be going on. Is that okay, everyone? Okay. Camera, please. Tell me how many cycle tests you have given so far? I will also check from my end. Yes, no, I have a report that will tell me who all have given all the cycle tests and who all have not given. So that's what I'm trying to find out. Okay, I'm going center wise. Okay. First I'm going to Borivali center. Shivam have given 4 cycle tests. Brandon, you have given, you have not given 3rd cycle test. Shubham, you have given all 4 cycle tests. Vishnu, all 5 cycle tests. Ashwin, cycle test 2 you have missed. Yes, I'm going to call out the current status and I will give you time and you have to complete it. That's why I'm saying. Cycle test 5 I think is scheduled for today. So Vishnu, you have given all 5 cycle tests. Ashwin, cycle test 2 is missing. This is for Borivali center. Thane center, Ashwin, you have missed 2 cycle tests. Kalyan center, Rahul, you have given 4 cycle tests. Komal, given 4 cycle tests. Sarvesh, you have given only 2 cycle tests. Southex center, Danesh, you have given only 3 cycle tests. Sheetal, only 3 cycle tests. Ankit, 2 cycle tests. Gulshan, 1 cycle test. Yash, 2 cycle tests. Sonu, 1 cycle test. Pankaj, 2 cycle tests. Abhish, you have not given cycle test 3. 1, 2 and 4 you have given. Mohit, you have also not given cycle test 3. 1, 2 and 4 you have given. Hina, you have given only 1 and 2 cycle tests. 1, 2 and 4, 3 you have not given. Jyoti, you have given 1, 2 and 4, cycle test 3 not given. Kanchan, you have given 1, 2 and 4, cycle test 3 not given. Sonu, you have given all cycle tests till cycle test 5. Vaibhav, these are all from Rajouri Garden. Sonu, Vaibhav. And the previous one was from Preetbihar. Rajouri Garden, Sonu has given all. Vaibhav, you have given all the cycle tests. Deepak, all cycle tests. Naman, all cycle tests. Vindhasini, all cycle tests. Siddharth, all cycle tests. So Rajouri Garden, everybody has given all the cycle tests. Rajouri Garden. All the cycle tests have been given. Connaught Place, Nandurani, you have given all 4. Surya Mugam, you have given all 4. Ankit, all 4. Rohan Upadhyay, 3 cycle tests. Yuvika, 4 cycle tests. Manish from Pitampura, 3 cycle tests. Pooja from Pitampura, 4 cycle tests. Chavi, 4 cycle tests. Kumar Ankit, all 4 cycle tests. Devanshu, 2 cycle tests from Gurgaon. Kormangla Rahul, all 4 cycle tests. Kemak Street Mohul, 4 cycle tests. Tuhin, Kemak Street, 4 cycle tests. Danesh, Kemak Street, 4 cycle tests. Dharmendra, Kemak Street, 4 cycle tests. Oshit, Kemak Street, 4 cycle tests. Anindita, Silchar, 5 cycle tests. Somdipta, 1, 2 and 5 given, 3 and 4 not given. Somdipta from Silchar. Devajyoti Silchar, you have given all. Dendang Sunet, you have not given cycle test 1, 2, 4 and 5. Rohan, PMR is supposed to be given on date. PMR is like your exam. So on that specific date, specific time, you have to come to the center and give the PMR. Okay? If your PMR can be rescheduled, if you are having some medical emergency, try to talk to your local faculty and GL. Only they can help, because individual center wise PMR rescheduling we cannot do. According to my schedule, whichever was the PMR date, everybody has given the PMR on that day. But you have not given the cycle test, Rohan, which you have to complete by today. Okay? By tonight, all of you, please complete cycle test 5. Is that okay? Rajouri Garden, everybody has already given. Rest of your name I have called out. And the guest students, their names are not there in the batch, that's why I have not called out. But apart from that, everybody will complete till cycle test 5 by tonight. Is that okay? Okay. So today we will complete the remaining portion of concurrency. If I ask you today that what have you understood about concurrency, will you be able to write it down? Tell me, what is concurrency? What is concurrency? What is concurrency? I believe all of you are typing. Yes, Akshaya, correct. Guest 1, Andheri, correct. Rahul Kormangla, correct. Ashit, correct. What about the rest? Yes, Bhavesh. Very correct. Very nicely framed, Bhavesh from Borivali. Very correct, Mohit. Raj Borivali, correct. Yogita, correct. Tit, correct. Ayush from Vashi, correct. Kanchan, that is partially, what you're saying is a feature of concurrency, or it's a feature of one of the classes of concurrency. Thread 50 is one of the features we get out of concurrency, but that is not exactly what concurrency is. Yes, Chavi, correct. Yes, Nandurani, correct. So that's great, that's great. Now, if you remember, we were doing the different synchronization in concurrency. We are saying that concurrency means one particular program will have multiple threads. Each thread will be redirected to each core of your CPU, okay, and they will be executed parallelly. So if that is the case, then why synchronizers are required? Why synchronizers are required? What did I tell you? It is, yes, Ankit Dubey from Connaught Place, you are correct about concurrency, but I am asking that if concurrently my threads are executed parallelly, why do I need synchronizers? Because synchronization means one after the other. Then why do I need synchronizers? Yes, Kanchan, it will definitely maintain a set of permissions, but for what? For what? Why do I need synchronizers? Synchronization means what? One after the other. In a synchronized way it will go on. One thread starting, another in pause, that second thread again starting, first one in pause, and in this synchronized way both the threads will be executed. But here if we are having multiple cores, why do we require it? Yes, that is very correct, Akshaya. That whenever you are writing a real life, you are developing a proper real life software and you are going to replicate your real life scenario, real life transaction into software, you will see that there are multiple programs or multiple threads of a program which are interacting with each other, or which are getting divided into sub-threads, sub-tasks, or if the program is very huge, then in if it is a quad-core core, or let's say octa-core CPU, in each core more than one threads are targeted. So that means in such scenario, you will have a single ALU to run and execute multiple threads. So though it is happening concurrently, why? Because when core 1 is executing a thread, core 2 is executing another thread at the same time. Okay? But then the third thread is again into core 1. Maybe the sixth thread is again in core 2. Okay? So multiple threads are running parallelly, but at the same time, because the number of threads are more, multiple threads are also waiting. Okay? So that's where you require synchronizers inside concurrency. Okay, the concurrency is the larger packet. Concurrency is helping you in executing multiple threads at the same time by separate cores of your CPU. At the same time, there are multiple threads which are which are targeted for the same core. So in those situations we will require synchronizations, and as Kanchan said, the synchronizers will help us in maintaining certain set of permissions, and with the help of those permissions we will be able to control that okay, how many threads can come in and wait in the queue. After the party count is 3, the barrier will close and the execution will start, or after every request it will be executing each thread like semaphore, or it can also exchange. Instead of waiting for the same core, it can use another resource and exchange or swap the object with some other thread. So these things which we were doing were with the help of synchronizer classes. What were the synchronizer classes we were using? Yes, Ashit, correct. Rahul, correct. It is to get a right lock, correct. So what were the classes we were using in synchronizer? Tell me the classes. You remember I explained the classes and I have also given you the theory. Yes, you have given 2 correct names, Nandurani. Yes, Kanchan, correct. Akshaya, correct. Yes, semaphore class, countdown latch class, cyclic barrier, phaser and exchanger. Correct. Okay. Very correct. One more feature we have to know apart from the synchronizers, that is executor service, where we are going to work with thread pool, and another is fork join. Executor service means that when the number of party counts increase, based on that growing demand, your thread object will be called, which means just like for example, let's say in a shopping mall, when you go in a shopping mall, you will see that there are 10 counters. In a shopping mall there are 10 counters, 10 POS, point of sale, where you can do billing counters. 10 billing counters are there. But if the number of customers are not very high, then you will see that out of 10, only 5 billing counters are working, rest counters are closed. Okay, they are not working. Why? Why does the manager instruct that? Why does the manager instruct to close down 5 counters? The manager can easily say that no, I have 10 manpower, 10 billing people, and I have 10 counters ready with 10 machines, 10 connectivities. I will open all the counters. So why does he not say that? Why does he close the 5 counters and keep only the rest of the 5 counters operating? Yes, Rahul correct. Rohan Upadhyay correct. Yes, Akshaya correct. Chavi correct. It will not reduce the manpower, Kanchan. It will reduce something else. Not exactly, Ashit. Yes, Andheri West guessed 1 correct, because we want to save certain resource. We want to save on the effort which we are giving. If I keep rest of the 5 counters open, it will be keeping on consuming the resource, like it's consuming a manpower who could be deployed to some other part of the shopping mall to handle some other situation. Okay, instead of putting it into a blank counter where there is no requirement, I mean you don't see any customer there. Okay, so how does it work? Give me the whiteboard. You have one billing counter, two billing counter, three billing counter, four billing counter. In the first billing counter, I have one customer, two customers, three customers. Till that time, second counter is closed. Okay, fourth customer closed. Now when the fifth customer comes, there is no more space and there is overloading of work in counter A. Okay, so then what will it be done? This counter will be opened. So they are ready, but they are not in use. The person who is deployed here in the counter was probably doing some other job in other part of the shopping mall. Okay, now that there is a requirement, this counter will open and the consumer will come. Second consumer will come. Third consumer will come. During that time, these are closed. Again, when the next consumer comes, then only this will be opened. That means service is executed as per the growing demand, right? Yes or no? If you have taken this, can I go to the next page? Taken? Okay. So similarly, you have a pool of threads. Okay? Many thread objects are present. These are all threads. Pool means what? Pool means collection. So collection of thread objects are present. So that will be called as a thread pool. So threads are already created and stored in a pool. Okay? Now from the user you are getting a request, and for serving this request you have to perform a task, and this task has got thread 1, thread 2 and thread 3. Okay, so now let's say thread object will be used for thread 1. This thread object will be used for thread 2. And this thread object will be used for thread 3. Which means I do not have to create the thread objects newly. The thread objects are already created and saved. But they are not in use, just like your ticket billing counters. They are created and prepared, but they are not in use unless and until the demand comes. So unless and until the task request comes, they will remain idle. And whenever the task request comes, this executor service will delegate the task among thread pool objects. Clear? Tell me everyone if this is clear. Yes, Kanchan, I will take you on air and explain this. Kanchan, adjust your camera and microphone. Hello, I'm not able to hear you. I'm not able to hear you. Hey, Kanchan, I'm taking Jyoti from Prithvi on air. Hi, Jyoti.
Hello?
Hello?
Yes, ma'am.
Jyoti,
Yes, ma'am.
Can you please bring Kanchan in your seat for 2 minutes?
Yes, ma'am. Yes, ma'am. Kanchan?
Hello? Hello?
Kanchan, look at this diagram first.
Yeah, ma'am.
This
Yeah, ma'am.
diagram is telling us that in a shopping mall there are a pool of billing counters available, but all the billing counters are not put to use.
Yeah.
Okay? And why are they not put to use? Because there are not sufficient requests. Number of requests are not as much as required. Are you able to hear me properly?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
So, because the number of requests are not that many, that's why though the billing counters are ready and prepared, yet they are not put to use. Okay? Similarly, in your Java environment,
Yes.
your thread objects are created and prepared in the thread pool. Okay?
Yes, ma'am. Yes.
They are not using
Yes,
it, but just
yes.
created and kept it.
Yes.
Okay? When
Yes.
request comes from the user, for
Yes.
serving that request, some task has to be executed. So executed service will execute the task by executing the task to some of the thread pool objects. So for each, because one task can have multiple threads, that is why it is multitasking. So each thread is assigned with each thread object. Each function task is assigned with each thread object which are already created. Okay?
Okay, ma'am. Okay. Okay, ma'am.
This task
Okay.
is done by executor service.
Okay. Okay.
If you have a question, you can ask. Please don't hesitate.
Yes, ma'am. Yes, ma'am.
Is it clear now?
Yes, ma'am. Yes, ma'am.
Thank you. Anybody has any doubt here? Anybody has any doubt here? Tell me, only 6 students are responding. Any doubt so far? Okay. That is done by executor service. The executor service is also a method. Another important thing which you have to know is fork join. This framework, I have maximized the screen. I'm doing it again. Now is it clear? Mohit, can you see now? Can you see the maximized screen now, Mohit? One minute, hold on. Pitampura, Andheri, Tidvihar, they are not able to see the screen maximized. So call them up, tell them. The screen is maximized from my end. Pitampura, Andheri and Tidvihar. Please call the technical person and request the person to help you out. Please confirm if you can see the full screen of the whiteboard. I'm continuing. So this framework implementation of the executor service interface. That will help us advantages of multiple processors. Okay, it is specifically designed break down large tasks into smaller pieces, threads, and redirect each subthread to different processing units. Okay? Clear? So, fork join framework is an implementation of the executor service that will help us to take advantages of multiple processors. It is specifically designed to break down large tasks into smaller pieces, that is subsets of threads, and redirect each subthread to different processing units. Okay? Clear? Let's say there is a task where there are two threads, thread 1 and thread 2. Thread 1 is again divided into T1, T2 and T3 threads. Okay? Then they reach individual processing units and then the fork join works. Fork join works and it again unites the output of 3 subtasks and gives a single output output. Okay, same thing happens here. One thread forking into 3 different subthreads going through individual processing unit. Fork join is joining them and is giving a single output. Each thread is broken down into sub-threads. Sub-threads, that is called forking, and when they are again joined to give a single output, that is called joining. So fork and join. Is that clear? All of you? Is that clear? All of you, please respond if this is clear. Fork join. Give me the camera. Is this clear or not? Whatever diagram I had drawn for fork join and whatever explanation I gave, that was clear or not? Yes or no? Am I not audible? Not getting response also. Please click on the answer. Am I audible or not? Screen was locked. Oh my god. How did the screen get locked? All of you, please respond. Now it is working. Oh. Have you understood the concept and diagram of fork join? Yes, Manish from Pitampura, I will take you on air. Manish from Pitampura, I've taken you on air, but there is no audio and no video. Call up Pitampura. Meanwhile, let me connect to Rohan.
Hello. I can't hear Hello.
You are not able to hear me?
Yeah, ma'am. No,
Why are you missing classes? Why are you not attending all classes?
No, ma'am. I don't miss my class. I am having doubts.
Louder. Little louder.
But I didn't miss my class. I am having a doubt. Right now you go out for join. Yes, ma'am. I was present.
And last class?
But I was noticed
Why?
Ma'am, it was with my idea was listen the system, but it was not working on the system, but it was just shadow.
Sorry, you were asking about
What ma'am? Okay, doubt. Ma'am, I didn't make the contract for zone.
Go to this one and tell me what you understand from it.
Yeah, ma'am, this separation is clear, but the diagram you told. Yeah, ma'am, this one.
So one task, this task is same as this task. Wait.
What ma'am? Yeah, ma'am, this is clear. Yeah, ma'am.
This task is executed how? If one thread is used, if one thread is used, let's say one thread is used,
Ma'am, could you wait for a while?
Okay.
Some of the students are talking loud. I can't hear you.
Okay, please get up and tell them to be quiet. Get up and tell them to be quiet.
Please. Hello?
Yes, so see, let's say one task has to be executed to serve a particular request, right? This task has got two threads, thread 1 and thread 2. Right? Now, thread 1 is of 20 MB. Right? 20 MB is a huge MB. I mean, if you redirect this 20 MB one single processor, it will take a lot of time. So what will fork do? What will fork do? Fork will break this one thread into smaller parts of subthread and redirect each part into each processing unit. Each processing unit is what? Each processor unit is CPU. But this is not a central processing unit. This is the core of the processing unit. One of the cores of processing unit. Right? So each thread, each subthread will be redirected to each core of the processing unit. And after they are processed, the output and given out as a single output.
We could also
No. Thread pool is implemented by executor service. The executor service is implemented by program. You can see this diagram. Thread pool is a separate class which is creating number of thread objects. Executor service is using those thread objects to create the task. To execute the task. But while execution, if any particular task is too huge, then the fork join splits that task, splits that thread into multiple subthreads and redirect each of the subthreads to individual processing units. After they are individually processed, the result is again joined back and given as a single output. Let's say for example, Rohan, you have gone to Pizza Hut and you have ordered for a pizza and pasta and let's say garlic bread. Okay, so three things you have ordered. Now pizza, for making a pizza you have a thread, and for making the garlic bread you have a thread. Okay, so let's say this is the pizza thread, this is the garlic bread thread. Now pizza thread will take 20 minutes time. So what will the fork join do? It will split it into subthreads. One thread will make the pizza bread, another thread will make the pizza toppings, and another thread will prepare the cheese. Okay, shred from the cheese and whatever, and they will be individually doing the task. After that, all three will be assembled together, baked into a single pizza and presented to you. So the single output is given to the user. User is not aware that how it has been made. But while it was being made, it was broken into sub-tasks and given to individual persons. That is what the fork and join are doing.
What is the sign? What is the output?
Sorry? What is the?
What is the sign? What is the output?
What is assigning and the output means? Whatever is the task that you have ordered for the pizza will be your output, but you don't know that in between the task of making pizza has been broken into so many parts. Somebody has made the bread, pizza bread separately, somebody has made the topping separately, somebody has made the sauce separately. You don't know that. Separate people have done the task separately, but because they have joined it together, assembled it together and presented to you. You know that there is one pizza. You don't know what has gone between. You don't know what the pizza has gone.
Ma'am, we could execute part. If you do the services providing the calculating task and the fork join is splitting the executor task. Splitting the executor service task.
Yes, exactly. Fork join is splitting the executor service task provided that one of the thread of the task is too huge. If executor service is executing a task with two small threads, then fork join will not even work. You don't need to deploy fork join at all. If the threads are small, you need to use fork join. Fork join will only come to the picture that one particular thread is being used.
Very clear.
Okay?
Yeah.
Anybody else? Anybody else has a doubt? Anybody else has a doubt? Please respond. Rahul from Kormangla, Rahul from Kalyan saying no. Only 7 students have responded. Okay. Give me the camera. I'll just take a small 5 minutes break. We'll come back and see the codes of cyclic bear, executor service and fork join. Okay? Let's take a small 5 minutes break. Everyone is back. Let us see the first example of cyclic barrier. Okay, I've prepared this demo. I've created a cyclic barrier runnable package with two files. One Java class is the runnable class, and another class is the class from where you are calling it, that is the main method. So cyclic barrier runnable is the actual concurrent class which you are creating, and cyclic barrier example is where you are calling the runnable class. So first let's go to cyclic barrier runnable. I have imported two packages, cyclic barrier and broken barrier exception. Then I have created cyclic barrier runnable class which will implement the runnable. Obviously every thread has to implement runnable, or it has to extend the thread class. It will make cyclic barrier object 1, cyclic barrier object 2. It will initialize it with null because initially these objects are not being used. Okay. Then a constructor with cyclic barrier object as parameter. Now since this object and this object are same, that's why we are using this keyword to assign the value from the parameter object to this object. Then we have the run method which will run, and in the try block, just like a normal thread method, we are putting this method in sleep for 3 seconds. It will wait for barrier 1, call the await method, again sleep for 3 seconds, again call the await method. The first await method, this one, this await method is called by first thread, okay, and this second await method called by second thread. So first thread is our barrier 1, second thread is barrier 2. First thread is calling await, second thread is calling await, okay, and it will be executed. But where is it getting called from? From the main method, which is in a different class. So in a different class we are creating a main method. Inside the main method we are creating runnable interface object, and we are giving it a body where we are overriding the run method, okay, where we are overriding the run method, okay, overriding the run method. Now in this run method we are just saying that barrier 1 is executed. That means this will execute after your first thread calls await method, then this will be executed, and then again the second run method, again we are overriding it. So this will be executed when the second thread object calls the await method in this. So when line number 25 is executed in this class, cyclic barrier runnable class, after that line number 9 to 14 will be executed in cyclic barrier in the main method, and when in the cyclic barrier runnable class line number 30 will be executed, after that in the main method line number 18 to 23 will be executed, okay. So then you are creating this cyclic barrier, whichever is the predefined class, cyclic barrier class, that class object you are creating with two parameters, okay, two parameters. This is a party count. That means it will wait for 2 threads. Both the thread objects will wait for 2 threads to get completed. First one will execute barrier action 1, second one will execute barrier action 2. This one, this run method and this run method, okay? So after that, cyclic barrier runnable object, this class object you are creating in the main method, and passing barrier 1, barrier 2. If you do not pass barrier 1, barrier 2, it will not work. Why? Because both the cyclic barrier objects are taking party count as 2. So I have to pass 2 objects for first barrier 1 object as well as second barrier 2 object. So for barrier runnable 1 object also you have to pass 2 party counts. Barrier runnable 2 also you have to pass 2 party counts. Okay? And then you have to start thread 1 and thread 2. So now when we run this package, wait for 3 seconds. 2, 3, thread 1 waiting, thread 0 waiting, again 3 seconds, again thread 1 waiting, thread 0 waiting, then both the threads are executed, thread 0 done, thread 1 done. I am executing this again and I am increasing the seconds from 3 seconds to 6 seconds. Then you will be able to understand. So after I start execution, count 6, and after the first output, count 6. 4, 5, 6, and then the output again 1, 2, 4, 5, 6, and then the output. Clear? Yes, Mohit, I will take you on air. Unmute your microphone, Mohit. Hello. Not able to hear.
Hello.
Yes.
Can you hear
Now
me?
I can hear.
Can you hear me?
Yes, now I can hear.
Ma'am, I'm not understand the code.
First, you have understood that there are two different packages, two different code files, cyclic barrier runnable and cyclic barrier example.
Yes, ma'am.
Cyclic barrier runnable is a class where we are defining the thread object, cyclic barrier object, and cyclic barrier example is a class where we have the main method and we have the overriding of run method from the runnable interface. Each run method is basically responsible for each cyclic barrier object, and each cyclic barrier object is taking the parameter of each run method, and each cyclic barrier runnable object, that is this class object, is referring to this cyclic barrier 1 and 2. Okay, and everything it is doing twice because we are creating two thread objects. The first class is cyclic barrier runnable. This is a plain simple class. Like instead of implementing runnable, you can write extend thread. Okay, you can write this also. If you remember my thread class, if you remember the class that I have taken for thread, I have told you that whenever you are working with any kind of thread, you have to either create a class by extending from thread, or you can create a class by implementing from runnable interface. Both will give you the same. Either you can write extend then thread class, or you can write implement then runnable interface name. Right?
Yes, sir.
Okay. Now, cyclic barrier is a predefined class against which we have learned. It is one of the synchronizers class. Remember semaphore, cyclic barrier, phasor, exchanger. I can see you. If you nod, I will be able to understand. I mean, everybody can see you.
Yes, ma'am. Yes, ma'am. Yes.
Yes.
It's like a time.
But you remember that you have done
I am not
day?
understand.
Last day we were doing. That's what I gave a recap, na? You joined late or what? Mohit?
ma'am, I am on my time, but
No, ma'am, I am on my time, but
So you remember I gave an example in the
difficult
beginning where I
to
was trying to,
understand
give you the logical flow that from thread where we stepped into concurrency and from concurrency where we stepped into synchronizers, and in the synchronizers there is one class called cyclic barrier. This is the most frequently used class. Cyclic barrier's property is to give a barrier. You know what is a barrier, Mohit?
No, ma'am.
That is the problem. So Java is not the problem, English is the problem.
Yeah.
Barrier means obstacle. So cyclic barrier means obstacle that comes in cyclic order, that is in repetition. So you are creating some obstacle.
Okay, madam. Okay.
Okay. Obstacle.
Okay.
Are you Hindi speaking?
Yes.
Okay.
Okay.
I think I'm not very good at Hindi, but I think in Hindi there's a word called बाधा या बाधाएं ऐसा कुछ होता है. Something which will stop you from doing something.
Yes, sir. Yes.
So that is exactly what this barrier is doing. It is, see, here you have given a party. If you go to the main method where it is calling the thread, it has given a party count of 2. That means unless and until 2 threads call the await method, unless and until 2 threads call the await method, none of the threads will be executed.
Okay, ma'am.
Okay? Something like your ticket counter. Unless and until 2 people
Yes.
comes and stand in the ticket counter will not open. 2 people have to come and wait in the ticket counter, only then it will open. So same thing, 2 threads have to call the await method, that means 2 threads have to be in the queue and wait, only then the thread execution will start. Okay, so you have created the barrier object, and you have created the cyclic barrier object here, cyclic barrier object.
Okay, ma'am.
Then
Yes.
you are using that cyclic barrier object to create a thread. Each cyclic barrier object will be each thread. So when you are defining the timer, like sleep for 6 seconds, sleep for 6 seconds, you are doing it twice. Each instruction for each barrier object. Okay? And this is what you are defining. This is what is the characteristics of the thread. But who will call the thread? It will be called from the main method. Then you are actually overriding the run method of runnable interface. Okay? From the runnable interface, when you write the run method first time, so this first time run method is calling line number 25. Line number 25 of cyclic barrier runnable .java. Okay? So when this run method is executed in this file, basically it is working against the line number 25 of this file, of the class. Again, when the second run method is taking place here, then this second time run method is calling line number, you tell me Mohit, it is calling this line number from this cyclic barrier runnable class?
27.
Sure.
sorry, madam.
Oh, sorry, ma'am. No, it's
Line
calling the line number 30.
30, correct. It
Yes.
is calling line number 30. Right? So whatever
Right.
object you created, that object is being called. But When you created the object, you created with a sleep time of 6 seconds. So even if it is calling, when the thread is starting, see, T1 is equals to barrier 1. Okay, because you are giving barrier runnable 1 to T1. And barrier runnable 1, you have given barrier 1 and barrier 2. Two obstacles. Two obstacles you have given to barrier runnable 1 object. And barrier runnable 1 object is given to T1. Okay? So when T1 starts, T1 calls refers to barrier runnable. Barrier runnable refers to barrier 1, barrier 2. Barrier 1, barrier 2 has 2 party counts.
Okay.
And for each party count, 2 run methods are executed. And against each run method, each await method is executed. And before each await method, 6 seconds sleep time is there. So when I am running this, so it is starting and waiting for 6 seconds to get executed at the first barrier. Again, it is waiting for another 6 seconds for barrier 2. So see, both the threads waiting at barrier 1, again both the threads waiting at barrier 2. After both the threads have done their waiting, then both the threads will be executed.
Okay. Then can you please send this code
I will send you the code, Mohit. I don't expect you to write also such kind of code now, because actual implementation of concurrency you will understand when you do advanced Java and advanced programming in Java. Okay. This is a concept in Core Java because here you don't require any web technologies. You can do it in Core Java also. This is dealing with your CPU and your thread. But basically the implementation, actual real life use is done only when you are developing a web development or a proper software. So I'm not expecting you to write such a code now. Give me the camera. I'm not expecting you to write such a code now. But I just expect you to understand the logic. That what is happening.
Okay.
Is that clear?
Yes, clear, madam.
Okay, so are you sure not in the group? So how do you get the code? Why are you not in the group? Join the group. It's a 2-minute start. Join the group. Okay, let's have the end of session question. So, I am showing you this one example. REST tool like executor service and fork join. All three together, cyclic barrier, executor service, fork join. I will share it in your group. And obviously you might have some doubt from executor service and fork join code. Coming week in cloud consultation, I will be sharing the times and time and all those things. So there I will give you the topics. Let's say 1 day for concurrency and 1 day for other doubt clearing. So the day I give you for concurrency doubt clearing, that day get your doubts clarified for executor service and fork join. Okay? Anything else you want to say? Anything else? Those of you who have not joined the group, please join the group. I will be putting them into zip files and uploading it in the group right away. So those of you who have not joined, please join the group. Anything else you want to say? Coming week there will be cloud consultations. Please don't forget to give your cycle test. I can see the report from here. Not many students are adhering to the cycle test milestone. So few are giving but few are not giving. So don't do that. Don't lose out on the marks. Give the cycle test. Please answer the question on your screen, all of you. Give your cycle test. Your SLT classes will not be there, but your cycle test will be there. There will be, yes, in one of the cloud consultations I will discuss about your MT. That what kind of questions will come in your MT. That idea I will give in one of the cloud consultations. Okay? Will that be okay, Pooja? Ashit, check your schedule. Next week, I think 19th is your cycle test. I'm not sure, but check it. Check your date for cycle test. Next cycle test, check it from nidstudent.com. Okay? That's it from my side. We can end the session. Thank you, everyone.